Hi class, and welcome to our next lesson. We're factoring the sum and difference of cubes in today's lesson. It's lesson 5-4, day 2. In 5-4, day 1, we reviewed a lot of different factoring techniques, such as if there is a greatest common factor, you have to factor that out first, and then you see if you can factor. If you have 4 terms, you factor by grouping. If there's 3 terms, you've got to try to factor with our 2 different binomials and stuff like that. And then we had 2 different terms, which we factored by the difference of 2 squares. This is when we had like x squared minus 49. What can this factor down to? Well, we talked about how it factors down into x minus 7 times x plus 7. So there's times that whenever you see 2 terms, what I first want you to think of is I want you to think of factoring using the difference of 2 squares, which is this right here. But that might not always work, so the second thing I want you to think of is factoring using the sum and difference of cubes. And that's what today's lesson is going to be on. So we're looking at this one. Sorry, let's talk about the equations first. Whenever we have a cubed number plus another cube number, it could always be factored into a binomial and a trinomial. And it's always going to have this look to it. It's always going to be a plus b, so this plus sign is in the middle, and then it's going to go minus plus in the trinomial. So it's going to be a squared minus ab plus b squared for that trinomial. If we have a cube number and another cube number, and it's the difference, so meaning there's a subtraction sign in between, it's very, very similar. As you can see, the a's go in the same spot, the b's go in the same spot, the a squareds go in the same spot, the a times b go in the same spot, and the b squareds go in the same spot. What's different is the signs. Now it's going to be minus, plus, plus. So in the sum of 2 cubes, it's plus, minus, plus, and in the difference of 2 cubes, it's minus, plus, plus. So that's the difference between the 2 formulas. So you got to pay very close attention whether it's the sum of 2 cubes or if it's the difference of 2 cubes. Let's look at this first one. I have x cubed plus 343, and my directions here on your next chapter test is going to be factor this. So you see 2 terms, so the first thing you should think of is this the difference of 2 squares? Well, x cubed isn't a squared number, 343 isn't a squared number, so it's not the difference of 2 squares. So now you need to think, is it the sum or difference of 2 cubes? And as you can see on this one, it is a sum, so there's a plus sign. Is it the sum of 2 cubes? Well, let's look at x cubed. Is this a cubed number? Is something times something times something x cubed? And the answer is yes. X times x times x is x cubed. So we know that this is a cubed number. Is 343 a cubed number? If it is, then I have the sum of 2 cubes. So is something times something times something 343? Well, if we take 7 times 7 times 7, 7 times 7 is 49, and 49 times 7 is 343. So we now have a cube number of x cubed, and we have a cube number of 343, which is 7 cubed. So what we have here, class, is we have the sum of 2 cubes. We're going to factor it to a binomial and a trinomial using this equation. So here's how I recommend that you do it. Always label what a and b are first. So what is a and what is b? Please write this down with me. A, the ones that goes in this spot and the one that goes in this spot, is the cubed root of this number. If this is a cubed, then this is a to the first power, so it's the cubed root of this one. So what times itself 3 times gives x cubed? We already talked about it. It's x. X times x times x is x cubed, so the cubed root of x cubed is x. Now what's b? b is the cubed root of this number. So what times what is 343? And the answer to that is 7. 7 times 7 times 7 is 343. So class, we have our a, we have our b. The rest of it is just putting it into the trinomial and putting it into the binomial. So I'm going to do that initially. Here's our binomial, here's our trinomial. Don't change the signs at all, just put the numbers into where you see them. So a plus b, that would be x plus 7. Because a is x and b is 7. So we have x plus 7 times a squared, so x squared, minus a times b, so minus x times 7, so minus x times 7 is a minus 7x, plus b squared, so plus b, which is 7, squared. And as we all know, 7 squared is the number 49. So here is my answer, class. I have successfully factored down the sum of 2 cubes. If you wanted to check your work, you can multiply these two by each other, and you should get right back to x cubed plus 343. So that's the basics of this. Once you've recognized that it's the sum of 2 cubes or the difference of 2 cubes, you label what a and b are. Once you label what a and b are, you put them into your formula. Let's try this one. We now have 8x cubed minus 27. So the first thing that should register to your brain is that there's only 2 terms, so you should see if this is the difference of 2 squares. Well, 27 isn't a squared number, nor is 8. So we ruled out that it's the difference of 2 squares. So now go down to your next check. Is this the difference of 2 cubes? It's a difference. 8x cubed. Is there a number times a number times a number that gives 8x cubed? Well, 2 times 2 times 2 is 8, and x times x times x is x cubed. So 2x times 2x times 2x is 8x cubed. So we have successfully found out that 8x cubed is a cube number. It is 2x raised to the third. Is 27 a cube number? Is there a number times a number times a number that gives 27? 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. So voila, we have 2 cube numbers, and we have the difference of them. So we're going to use this formula. So let's first recognize what a is. A is the cubed root of this first term. And the cubed root, so what times itself 3 times gives 8x cubed. 2x is the cubed root. So basically, what's the cubed root of 8? It's 2. What's the cubed root of x cubed? It's x. So 2x is my a variable. My b is the cubed root of this number. And the cubed root of 27 is the number 3. So we have successfully found my a and b values. Now it's as simple as plugging it into the binomial and the trinomial. So I'm going to make that. Here's my binomial. Here's my trinomial. My binomial is a minus b. Again, don't change any signs here. Keep the signs right where they're supposed to be, because that's how the formula works. These signs are built in to make it work. So a minus b is 2x minus 7 times a trinomial, a squared, so it's going to be 2x quantity squared plus ab, so 2x times 3 plus b squared, and b squared is 3 squared. Let's take one more step to simplify this. Your first binomial is already good to go. It's 2x minus 7. Your trinomial, what's 2x times 2x? 4x squared. What's 2x times 3? A positive 6x, and 3 squared is your positive 9. We have successfully factored the difference of 2 squares. So that is our answer for problem number 2. You guys pause the video and try number 3 on your own, please. After trying problem number 3, hopefully you found that this is the sum of 2 cubes. So we're going to identify what a is. A is the cubed root of 125, which is 5, and the cubed root of x cubed, which is x. So a is the number 5x. B is the cubed root of 64, and the cubed root of 64 is 4. Hopefully you all did that successfully. Now you're going to put it into this binomial and trinomial. So the binomial is a plus b, which is 5x plus 4. The trinomial is a squared, so it's 5x quantity squared minus 5x times 4 plus 4 squared. So as we simplify the trinomial, we still have 5x plus 4 in the binomial, multiplied by 25x squared, because 5x times 5x is 25x squared, minus 20x plus 16. And there should have been your answer for problem number 3. 5x plus 4 times the quantity 25x squared minus 20x plus 16. Last one, problem number 4. We see this one, 5xy cubed minus 40x. So your brain should register, this is 2 terms. Let's see if it's the difference of 2 squares. It is a difference, but 40 isn't a squared term, 5 isn't a squared term, so we're kind of stuck thinking of that. Our very first check of any of these factoring ones is to take out a greatest common factor if you have one. Well, both terms have a 5 in common and they have an x in common. So I could factor out 5, I could factor out an x. Once I do that, after I've taken 5x out of the first term, I'm left with y cubed. And after I've taken a 5x out of my second one, I'm left with 8 all by itself. After I've taken out a 5 out of 40, I'm left with 8. And after I've taken out this x, there's no more variables left. So I've factored out the 5x, and now I'm left with y cubed minus 8. Now, hopefully you can recognize this rather quickly. This is the difference of two cubes. A is the number y, and b is the number 2. Y times y times y is y cubed, so a is y. 2 times 2 times 2 is 8, so b equals 2. Now I'm going to factor it. I'm still going to have my 5x on the outside. Here's my binomial. Here's my trinomial. I always kind of like to think of my signs and put them in right away too. It's minus plus plus, so now I'm going to have a minus and a plus and a plus. And then it's going to be a minus b, so y minus 2. That equals a squared, which is y squared, plus ab, so plus y times 2, which is 2y, plus b squared, and b squared is 2 squared. 2 squared is 4. And we are done. So that is the answer for problem number 4. Hopefully that makes sense to you. Always remember, whenever you see two terms, you got to think, is this the difference of two squares? If it is not, now go to the difference or sum of two cubes. And then you just follow your formula. Let me know if you have any questions when you get to class tomorrow.